I'm going to take everyone through a little bit more in-depth conversation specifically around Kubernetes and how you can take a sort of a little known resource, or I guess underutilized resource is probably the better way to phrase it, the Kubernetes events, and extract value from them. And there's kind of like a multitude of ways you can do that. I'm going to show you how you can do it straight from like the CLI or using an observability platform like ContaiNIQ. Awesome. So what is a Kubernetes event? It's basically like, it's a Kubernetes object that's showing like a kind of a change that happened in your system. So, maybe it's a pod being created. Maybe it's a stateful change in the node. The node went from, ready to unready, or, maybe there was a networking change that happened. It really, it sort of acts as like a historical log of everything going on in your cluster. And something, like I said, I think people don't realize like all of kind of the value you can really extract out of having that log. So like, what's the structure of the event? It's basically broken down into the type. So normal or warning. Obviously, normal is just something that's everyday occurrence that you shouldn't be too worried about. And warning is something that's probably worth investigating depending on the setup of your cluster.
Just Matthew, just sorry to interrupt. Are you showing your deck right now? Because if you are, I can't see it. What I'm seeing is your terminal.
Oh, interesting. I guess I was going through the deck. Let me repurpose this.
It's always a juggle with desktops, isn't it?
Yeah. Is it still showing wrong screen?
So now we're seeing. Yep. Okay. There you go. There. Yep. There we go. Yep.
All right. Well, I didn't go through much. I really just hit the first 2 slides here. Like, what is an event, and the structure of the event. So the structure being normal, warning, for the type, and then the reason and message. Reason, it's just kind of like a quick, unique snapshot of it, and message is like a more in-depth explanation. So you could see like the reason here, like the node is sufficient memory, and the message, which is just like a longer explanation of it. So in order to get a list of your events, you can just run kubectl get events. It'll list all of them in your cluster. In order to see a specific event or event specific to a given Kubernetes object, you just run kubectl describe the object and then object name. So in this case, like kubectl describe pod and then the name of the pod. And I can actually just I'll show kind of a walkthrough later of that. I can't actually flip up my terminal now, but yeah, it's pretty straightforward. It'll list like all of the events for that given Kubernetes object. So what are the typical use cases for events? Debugging is one of the most common. So like maybe something's wrong with one of your pods and you want to know why that is. One of the first things I might do is run kubectl describe pod and then the name of that pod, and it's going to show me all of the events that happen. So I'll be able to see maybe the pod recently restarted or it was evicted. It'll basically give me kind of the life cycle of that pod, and I can quickly figure out what's going on. Next is alerting. So you can set up alerts on a lot of these Kubernetes events. And the cool thing about them is they're usually something that, you can set them so that you need to look into them. An example is like, say you set up a CPU alert on, a given container or pod, and it fires so often that you've learned to ignore it. With Kubernetes, what you can do is you could, set up a CPU alert on a node through the, node CPU limit reached. And what this means is that that node is basically out of CPU. And so like we have an alert set up on that. And if that fires, I know it's something I need to investigate. So it helps by using kind of the event feed for alerting. You can sort of get rid of those white noise alerts if you use them correctly. A final thing is like using them for analysis. So like I said, it's this historical log of everything that's happening in your cluster. Maybe you want to see how often you're deploying or how often a given autoscaler is autoscaling. You could aggregate those autoscaler events by hour over the past week, and you could see not only how many times is the autoscaler scaling up, but at what times of day. Maybe it's not what you expect. So you can kind of use it to just get better idea of maybe traffic patterns or just the life cycle of events in your cluster. So yeah, it takes me into lifecycle events. One of the more confusing things with the events too is that it's very difficult to figure out like all of the events that are available for you. There's not like one giant list out there that has every event. This is kind of twofold. The first is that any CRD, so custom resource, basically can have its own events that it fires. So maybe you're using some third-party CRD that's a little bit lesser known. It's going to fire all of its own events. But the events themselves are also split into each individual object. So like I've found myself looking at like the pod, the code for a pod in the Kubernetes GitHub, and that's going to have all of the pod related events. So they're kind of like disparate in where they're located. So it can be difficult to figure out what events to look for. Luckily, I've seen a lot of them at this point, so I'm here to help you guys figure out the important ones. And another great way is just by like watching your cluster periodically and seeing which events are firing. Downside of this is that by default, EKS, so Amazon's managed Kubernetes offering, only stores events for, I believe it's 5 minutes unless they refire. I think like a vanilla K8s install is like an hour. So if you're not exporting them to some external system, you might be missing a lot of things. And that's just something you want to be aware of. So yeah, let's get started with lifecycle events. What are lifecycle events, and how can you use them? So some of the most common ones are the start hooks that fire when a pod is created. So maybe every time a pod is launched, you have some script that runs that provisions things or does something related to your application. Every time that occurs, Kubernetes is going to fire an event. And so something that we watch out for specifically is this failed post stop hook, because every time we delete a pod, we have a script that runs that basically does some meta-analysis on it. And if that fails, it's pretty bad for us. So we need to know whenever that post stop hook fails. So this is an example of something we would like set an alert on. Another great example is the unhealthy event reason. And so this will fire anytime a probe fails. So like we mentioned earlier, like, how do you know when a given, microservice isn't responding? Well, Kubernetes will actually constantly probe each pod. And when that probe fails to respond, or, when it times out, or, maybe you say notify, you set it to a threshold of 300 milliseconds. When it's greater than that, that threshold, Kubernetes will actually fire this unhealthy event. And that could be another thing that you could set an event alert on. So you could know, hey, this pod has stopped responding. The cool part about this too is that, maybe previously you've got a bunch of, you set, kind of uptime alerts to ping your website, periodically. And every time you add some new DNS or a new endpoint, you have to add a new you have to configure this new ping, the unhealthy hook will always fire. So it's something that's kind of like readily available for you that you don't have to continuously configure yourself. Finally, back off. So that's like anytime you launch a pod, it crashes, it goes into like a crash loop back off. This back off also applies to Kubernetes jobs. So if you have a job that's running and it fails, it'll fire the back off reason once it exceeds the number of retries. So if maybe you want to get notified every time a deployment essentially fails, you could hook into that crash loop back off or back off event. Next, there's a bunch of node specific events. So these could be used to basically monitor all of the nodes in your cluster. So while there's things that are good, like node has sufficient memory, there's also the opposite, which is when your node runs out of memory. So you could do the same thing for, node doesn't have sufficient memory, or node CPU limit reached is a great example of an event that will fire. That will be less noisy than setting your own CPU base limit. So node memory limit reached and node CPU limit reached are two ways that you can monitor basically the health of your nodes while kind of limiting that white noise of like, send me an alert when CPU is greater than X. This will obviously depend on your setup of your cluster, because if you have a cluster autoscaler setup, maybe it's okay if your node runs out of CPU and memory because you're going to add a new one. But for people who don't, this can be like a helpful way to kind of like match those use cases. The other cool thing is, like, say you set a CPU limit on or alert on a given node, and then later on your team resizes the number of cores on that node, and now there's a lot more CPU, and your old alerts are still firing because you have to now go and update all of them because you've changed the size of the node or the VM or whatever the underlying resource is. Like this, the node CPU limit reached event is going to be reflective of the actual underlying hardware, even if it changes. And in this kind of like new norm of ephemeral resources that Kubernetes kind of offers, it's a great way to just reduce the overall burden of having to kind of like update things as you go. Evicted events. So this is, in most cases, it's a precursor to things going wrong. So what an eviction is if your cluster is running out of resources or a given pod is reaching its limits, Kubernetes will start killing pods. So basically things are, in most cases, starting to go wrong. You're hitting some resource limits. We see this when there's like a lot of like, when load's really high. And so this is another great thing that you can either set an alert on, or you could potentially use for analysis. So certain people are okay with eviction events. They are, if a bunch of pods get evicted from a given node, they they may have planned for this, or they're used to the node automatically kind of scaling up to meet the new demand. But for us, it usually means things are going wrong. So it's something we're going to want to look into. Now, after that is storage specific events. So this is related to like anyone who's setting up some type of volume on their like pod, or maybe you're setting up some type of like persistent volume storage. And the two key ones to look out for here are failed mount and failed attach volume. These will happen when maybe you create a new pod, it'll try to attach your volume to it, it won't work, it'll fire this event. there's a lot of like config maps that are passed in through volume. So it could mean that your pod doesn't have the necessary config variables, and you're going to see kind of like these cascading failures from here. So definitely something worth looking into if you kind of consistently see it. Sometimes Kubernetes will auto recover from these events. I've seen at least, but it's something that you should at least be kind of aware of. Next is scheduling events. So this is kind of more related, similar to like your lifecycle events. So you can catch basically failed scheduling through the scheduling events. So example is like you might want to set a event alert on failed schedule. And this means that Kubernetes, you have a pod and you want to deploy this workload, and Kubernetes went to schedule it and it can't put it on any node. The workload's not running, not great. It could be that there's no nodes available, there's not enough resources available, or maybe you have some taints or toleration set up that are preventing the scheduling. So definitely, most cases, something that you're going to want to look into. Scaling events, kind of like wrapping it up here, are anything that fires like either through the horizontal pod autoscaler or the cluster autoscaler that are going to let you know, kind of related to load, like if you're adding or removing pods. So this is mainly used for analysis. I often look into this to see like when are we scaling, what times of day is the autoscaler running. Can kind of line it up with like performance. But yeah, more for like looking at like analysis in the cluster. Yeah, and that's kind of like the quick overview of like the different types of Kubernetes events, which ones you should be looking out for. And from here, I was going to, just bring up my terminal, kind of show you guys some like example use cases. There's a bunch of different tools you can kind of use to drill into these events. One of them being like ours, but there's, you can use like the terminal. You can use something like setting up like the Prometheus event exporter. I think there's like tools out there to do that. And you can kind of like ship them to whatever system you want. So yeah, I'm just gonna pull up my terminal here. Hoping everyone can see this. Cool. So yeah, the two events, or the two commands I described earlier, were kget events and k-describe the object and then the resource. So an example of kget events is you're going to see, all of the recent events in your cluster, the message saying what's happening, of reason, which is kind of just like a short description, the object it came from, and the type. So like this is a great example because like failed get resource metric, it's not something I might not have even known about, but what's happening. The pod autoscaler can't get CPU utilization. So what does that most likely mean is that the pod autoscaler isn't going to work correctly. And so this is something that like could have affected, us scaling up in the future. It's something that I wouldn't have even known about if I hadn't have like looked into these events, or if I wasn't, exporting them somewhere to look into. The downside of just doing everything from the terminal is, show you another example. So let's take this evicted pod right here. And K is just an alias for kubectl. It's essentially what I'm doing here. I'm going to describe this pod. And so I'm describing a pod that was evicted, right? So I know that there should be some evicted related events, but there's none. And so why is that? It's because by default, Kubernetes doesn't store these events for a long time. And so if you're not exporting them to some external system. You're just going to like lose some of the data. So kind of the key thing I'm harping on is, whether it's Prometheus or some other observability tool. I think it's, the first step is just sending them somewhere so you know what type of events are even firing inside of your cluster. Because, or else you're going to lose them. That's why if you saw that, like, when I ran the get events, there's only 4 of them, and they've all fired pretty recently. It's because all of the older events are gone at this point. So yeah, just a lot of the cool data you're going to lose if you're not if you're not pushing everything somewhere else. Yeah, then I guess like the last thing I was going to walk everyone through here is kind of some analysis you can do. I'll give an example through ContaiNIQ, but there's a lot of different tools you can use for this. And so, yeah, one of the things we do here at ContaiNIQ is help people, monitor, observe, and alert on Kubernetes events. And so, like I said, to get the most value, you're going to want to export them somewhere. And it's kind of actually where we started, was a better way to store and alert and visualize all of this like cool event related data. So yeah, at a high level, like, okay, now you've got all this event data. What are some things you can do with it? So I think something that we do that's interesting, or something that I'll do, is I'll look at the scaling replica set event, and I'll see, over the past week, how often is our replica set scaling up? What times of day is it happening? And I'll segment it by like hour or minute or whatever, to get an insight into, how often is this occurring? Maybe I find out that we're constantly scaling up, and I need to, maybe tweak the thresholds where the scaling's happening a little bit, or maybe the scaling's leading to other issues. You can kind of just get like a deeper insight by graphing these different events over time. Another super common use case is just like looking at your warning events to know, like, you might not even realize what you should be looking out for, because the warning events fired and now they're gone. And so you don't even know. And so, yeah, I'll just like open up the warning events, I'll drill into like maybe a given time period. And then I'll, kind of paginate through them to just get an idea of like, okay, what happened over the past 24 hours in relation to warning events. So you can see there's some related to like pulling an image, some like failing to attach a volume, which is something I mentioned earlier. So this, I would want to like investigate why this is happening. Yeah, it basically just gives you a way to kind of see like what exactly is going on in the cluster. The final thing is you can also just search any Kubernetes resource. So similar to when I ran that kubectl describe pod, you can essentially search any pod or resource name in a tool like ours, and it'll show you, all of those events for that pod. And again, like you don't have to worry about them being discarded. We also automatically associate logs, which is kind of a nice addition, because maybe your pod went into a crash loop. You want to know why that is. We'll automatically pull in the logs at the time that the crash loop occurred, so you can see, maybe your container was logging an exception, just causing the pod to be restarted, and then it restarted enough, it went into a crash loop, and now your application's not running at all. Basically just giving you a better way to debug why things are going wrong, which we kind of talked about at the beginning, is super important. Once you have the alert, now it's time to figure out, how do I resolve this as quickly as possible, and so it affects the least amount of users. Yeah, I guess like the final kind of thing is you can also set event alerts. So I will often set alerts on a lot of the things in the slides I showed earlier, but we enable basically default alerts for people where we will set up alerts for things like failed scheduled events, pod evictions, node CPU and memory limit breached, really any precursor to outages inside of your cluster. And yeah, with that, I will kind of open it up to questions from anybody. If anybody has any questions or thoughts, happy to answer them here.
There was a question that came in from Harsha earlier, which I'll pose to you, which is what tools are you using for observability aside, I guess, from ContaiNIQ?
Yeah, that's a great question because there is a ton of tools out there, and I think what you should use depends on a lot of your situation and maybe your familiarity and experience with those tools, as well as like your budget. So internally, we heavily dog food all of our own tools. The reason for this being kind of like we have some like kind of native insights that you won't necessarily get out of the box with other tools, and they're super important to our specific kind of use cases. And so like we essentially need to use our own tool for those. But for like, I guess like more general purpose, I think it's pretty common to see people using something like Prometheus to gather metrics. It's essentially like a time series database. The graphing capabilities they're good, but they're not super user friendly. So typically you're going to want to export those metrics somewhere else, maybe something like a Datadog or Grafana or a New Relic. You're going to want to like send that data there for kind of like the visualization and alerting. For us, it's really, we're using like Prometheus to grab the metrics, we pipe them into our own system, and we use like our own tool internally for like monitoring and alerting. Yeah, there's a lot of tools out there. I think in Kubernetes, the most common use case is probably Prometheus, Grafana. That being said, I've heard a lot of people say that if you don't have a team dedicated to it, you should look for a more managed solution because it can be monitoring can be scary, and you can definitely run into some issues and bugs. So depending on your experience, I think that determines, and the size of your DevOps team, I think that determines, whether you're looking to self-host or use a managed solution.
I've actually got a couple more questions that I'm going to pass your way, if that's all right. One came from Pasan Don. Does ContaiNIQ integrate with Prometheus or Kibana, or are they does it exist outside that sphere?
So the way ContaiNIQ works is essentially we collect all of that data for you, so you don't have to run those tools yourself. You can still like push Prometheus data. The goal of ContaiNIQ is really to reduce the workload of you having to run those tools yourself. So like we'll automatically collect and aggregate your logs for you and correlate them with events. We'll automatically collect metrics and all of that stuff for you so that you don't even have to worry about Prometheus. We will like integrate with some of those tools, but our goal is that, you don't even have to worry about them.
That's cool. Kind of related. There's a question in the chat from Amruta Bandhu, and these events that you've been describing, they're sort of correlated and dependent on each other. So I'm guessing what ContaiNIQ kind of does, like you said, you're collating all of it to kind of get an insight into sort of the kind of how the sort of relation of various events happens, and sort of to provide a kind of insight and actionable sort of thing that you can go from there. I butchered that question. I'm sorry.
No, I got the general direction. Yeah, I mean, the correlations, the most common correlation we see is actually not even necessarily with other events, but it's with logs. Like you're going to want to see maybe the logs that in the pod that were firing at the time the event occurred, or if it's more of like a system level event, maybe an event in Kubelet, you might want to see the Kubelet logs right as that event was firing. So I think the most common correlation is not necessarily between the different events, but it's between events and other things. So logs, metrics, information like that. And you can always roll it up like through the aggregations to like, graphing how often a given event occurs over time by like segmenting by like hour or day or whatever.
Yeah, I really like that example that you gave where it was like these scaling events kind of happen, like do they happen every 6 hours or whatever, and then you can kind of relate that to other things that you know about based on your other monitoring. Is like, okay, this happened because we see this morning spike when everybody comes in and does whatever, right?
Yeah, it's kind of like the DevOps nerd in me loves seeing that. It's like, okay, when's our load coming in? When are we scaling? It's definitely a lot of fun to kind of graph those different things over time.
Yeah. I think Amrita's just followed up. It's like any tool for this correlation. I guess a lot of it is just, I mean, it's not so much a tool, it's a process, isn't it? Correlating that stuff, like knowing what you're putting together. Right?
Yeah, I think we're obviously like a tool that offers like a lot of the log event metrics correlations, but it's really anywhere you pipe the data that gives you the ability to kind of like graph multiple things over time. That's kind of the core of what you're going to need for the correlations. So just a system that accepts a bunch of different ingest and will let you correlate across like those kind of different ingest feeds.
Yeah. Cool. Well, I've just seen a YouTube question as well. Is there's a ton of tools out there, but what are beginner-friendly tools for monitoring and observability? And I'm guessing, ContaiNIQ is, considering that this is all fairly complex stuff anyway, and Prometheus is difficult. ContaiNIQ kind of looks like it's a friendlier way. But you also did mention like, various other subscription type tools. But maybe have you got any ideas about like what are beginner friendly sort of monitoring tools?
Yeah, so yeah, and obviously that's kind of the inspiration for why we built this, is because I was super unhappy with a lot of the other tools, and I thought we could really simplify some of the data and correlations, the common use cases that people needed. I think generally, this is kind of just my opinion, the paid solutions are generally more user friendly. Mm-hmm. The open source tooling is generally a bit more work. Just from talking to people in the industry, if you're using like a setup like Prometheus and Grafana, you're usually going to need a team to stay on top of that. We've seen a lot of cases where people set it up and either things went wrong or they're like, this is just more headache than I originally imagined, and then they migrate to more of like the paid tools. So yeah, I think generally that's where you're going to see the more ease of use focus. But if you want to get your hands dirty with like some more complex stuff, that's free and open source, Prometheus, Grafana, Thanos, Loki, Jaeger. That's kind of like the stack you're going to need to get the full insights. Again, it's going to be much more kind of like complicated to set all that stuff up though.
Yeah, and you can set it up exactly the way that you want it to, but you're dedicating your own time and resources to doing that. As much as really good dashboards, for Grafana already exist out there, like you'll still have to probably fine tune it for your specific use case.
Yeah, I think it's entirely dependent on what type of data you're looking for. If it's just, simple metric level data, then might not be that worth to set all that up. But if you're looking for like trace to log correlations, and like automating a lot of that stuff, it becomes a lot more involved. So again, your mileage may vary, and it really depends on the use case. It's hard to give a concrete answer.
Yeah, no, fair enough. I mean, it as with everything, it depends, right?
Exactly, which I'm sure people hate to hear.
No doubt.
But it's kind of the truth in this case.
Yeah, because if there was only one defined way of doing things, then we'd all be doing that, and there would be no innovation or whatever, and there is tons of innovation in the space. So it proves that there are good new ways of doing stuff.
Everyone's trying to do things just a little bit better than the previous generations of tooling. So it's the landscape's constantly changing, and with things like eBPF, which is a pretty cool new technology I recommend people check out, which allows you to like hook into the kernel directly. I think like the possibilities of what you can monitor and what you can get out of the box are really changing, and you're going to see a shake up in the landscape over the next few years.